In this video, you will learn how to use systems of equations to problem solve. Now, up to this point, with any sort of word problem, we have only worked with one variable. So using one variable, for example, we could have solved a problem like this, where Kai has 12 coins, all dimes and quarters, worth $2.25. How many dimes and how many quarters does Kai have? Now, using the old method, we would create a table, and we'd have dimes and quarters. We'd have on the column the number times the value per coin equaling the total value. And we would use a variable such as x and let that represent one of these unknowns. So if x were dimes, then the number of quarters is going to be 12 minus x, because we have 12 coins total. So the number of quarters was 12 minus the number of dimes. So we kept it with the same variable, with x and x in both of them. And then we can find the value per coin to be 10 cents for dimes, and then 25 cents for quarters. Then multiply both of those columns together to get your total value. So here we'd have 10 times x, and then over here we'd have 25 times 12 minus x. Now, once we have this information, we can then use this total column to create our equation. So we note that the only fact that is not included in the table is the total values of the coin, and that is the 225, all right, which is 225 cents. So I can use that to write the equation. I know that the value of the dimes plus the value of the quarters would add together to give me $2.25 total, or 225 cents. So this is my equation. 10x plus 25 times 12 minus x equals 225. And from here I then proceed to solve by distributing. 25 times 12 is 300. 25 times negative x is negative 25x. And then combine like terms. 10 minus 25 is negative 15x. So negative 15x, and then this 300 I can bring to the right. So negative 15x plus 300 equals 225. I can then subtract the 300 over. We get negative 15x equals negative 75. Then divide by negative 15 to get x equals, then 75 over 15 is 5. And it's positive because negative divided by negative is positive. So x is 5, which is the number of dimes. And then the number of quarters is 12 minus x, or 12 minus 5, which is 7. All right, so this is all using a method we've learned in previous lesson. And this is using one variable. Now in this lesson, we're going to do the same types of problems, but now use two different variables and use our systems of equations in order to solve. So if you had the exact same problem and you were to solve this using two variables, what I would do is I would let a variable represent my first unknown, which would be dimes, and a variable to represent my second unknown, which is quarters. So I can let D represent dimes and Q for quarters. And then the value per coin is the same. We have 10 cents for dimes, 25 cents for quarters. And the total value is going to be calculated the same way. We have 10 times D and then 25 times Q. So now from this point, I need to use the table and use my other pieces of information to create two different equations. So notice the two things that we have not used in this table. We've not used the fact that there are 12 coins total, and we've not used the fact that the total value is 225. So I can use those two different informations to create two different equations. So the first of which would use the number of coins. So I know that the number of coins totals to be 12. So looking here at this number column, if I add up the number of dimes plus quarters, that gives me 12 total. So my first equation could be D plus Q equals 12. Dimes plus quarters is 12. And now I can create a second equation using my total value, which is 225. And that requires us to look at this last column. So if I add up the value of the dimes, so 10D, add that with the value of the quarters, 25Q, that will total 225 cents. So 10D plus 25Q equals 225. So from here I have my two equations, and at this point I can then solve. So the only thing new with this lesson is the fact that we need to create our two equations from a given word problem. The solving process we have already learned how to do. So if you're good with the solving process, you can skip ahead in the video to the next problem. But I will walk you through to give you some practice with solving these types of problems. So here, as a review, if you want to solve this, you want to pick either equation to solve for and pick one of the variables. So notice in the first equation we have D and Q, both of which have nothing in the front of them. Right? There's no coefficient. So either would be easy to solve for, and let's pick D just because. If I solve for D, what I would do is I would solve by subtracting Q from both sides. So I now have D equals 12 minus Q. So once I've done that, I can then plug 12 minus Q in place of D of the second equation. So instead of 10 times D, we have 10 times 12 minus Q. Then plus 25Q equals 225. So to solve, I can distribute 10 times 12 and 10 times negative Q to get 120 minus 10Q. Then these can combine. Negative 10 plus 25 is 15. So I have 15Q. And then I can solve for Q by subtracting 120. So I have 15Q equals, that would be 105. And then divide both sides by 15. That's going to give me Q equals 7. So Q is 7, and I can use that to find D. We said D plus Q is 12. Right? We can use either equation. D plus Q is 12. Plug 7 in. So D plus 7 is 12. So that would give me 5 for D. So again, using this different method, the number of dimes is 5, and the number of quarters is 7. Here is another example using a system of equations to solve. We are told that Kira and Caitlin together have $50. Kira has $6 more than 3 times Caitlin's amount. How much money does each have? Now to begin, we want to establish our variables. So we want to know how much money does each girl have. So we can let K be Kira's amount and C be Caitlin's amount. Alright, so from here we want to use information given. So we know that together they have $50. So if I add Kira's money plus Caitlin's money, that would equal 50. So K plus C equals 50. So that is one equation that I can use. The other thing that we know is that Kira has $6 more than 3 times Caitlin's amount. So I can create an equation from this. Kira has, so her amount is equal to 6 more than 3 times Caitlin's amount. So I do 3 times Caitlin's amount and add 6 to that. So 3C plus 6. And that is my second equation. K equals 3C plus 6. So with these two equations, notice that this one right here is already solved for K. So what I can do is I can simply plug in this 3C plus 6 in place of K. So at the first equation, plug in a 3C plus 6. So now we have 3C plus 6 plus C equals 50. Solve for C. We have 3C plus 1C. That gives me 4C. And then subtract 6 from both sides. We would have 4C equals 44. And then divide by 4, C would equal 11. So if C is 11, I can use either equation and plug C back in to find K. So using the first one, K plus C is 50. We plug an 11 in, So now we have k plus 11 is 50. Subtract 11 from both sides, k would equal 39. So Caitlin's amount is $11 and Kira's amount is $39. And we can always do a mental check and see if our answer is correct by looking at the given information. So together they have $50, so that is true. 11 plus 39 is 50. And Kira has $6 more than 3 times Caitlin's amount. And that is also true. 3 times 11 is 33, and add 6 to that, and that gives me 39. I have 2 more examples that I'm going to walk you through. For example 3, we are told that Larry invested $6,000 in stocks and bonds. The stocks pay 5% interest and the bonds pay 7% interest. If his annual income from the stocks and bonds is $400, how much is invested in each? So first off, you need to understand how interest works. So if you've not learned in the past, here we're going to explain briefly how you can calculate interest. So interest is found by taking what we call the principal, or the amount invested, multiplying it by the rate, then multiplying that by the time. So your formula is interest equals principal times rate times time. So for example, if you invested $1,000 at 5% interest, you take $1,000 times that by 5%, or 0.05, and then let's say we invested for 3 years. You would multiply those numbers together, the principal times the rate times the time, to give you the amount of interest earned. So in this example, we have 3,000 times 0.05, which would equal $150. So that would be the amount of money earned from that investment. So using that information, we will want this formula here in a moment to determine one of our equations. So as we begin this, we first must define our variables. So we're trying to find how much is invested in stocks and how much is invested in bonds. So we'll choose the letter S for stocks and B for bonds. So that's the amount invested in each. And what may be helpful is if you create a table. All right, so what we could do is create a table where we have in the row headings, we have stocks, bonds, and then the total amount. And then our column headings, we have our formula, principal times rate equals interest. And time would be in here too, principal times rate times time, but because time is just 1 year, annual income 1 year, time is 1, so when you multiply it doesn't really affect anything. So you could just do it like this, principal times rate for this particular problem. All right, so from here we plug in numbers into the table. So the principal is the amount invested. So for stocks, that is the letter S. For bonds, that was the letter B. And then the rate for each is given. So stocks pay 5% interest. So the rate for stocks is 0.05. And the bonds pay 7% interest. So the rate for bonds would be 0.07. And we said interest is principal times rate times time. And time is 1 year, so just ignore the time aspect for this problem. So just take principal times rate. We have, for stocks, we have S times 0.05, or 0.05 times S. Bonds is B times 0.07, or 0.07 times B, same thing. And we also know the total. All right, so the total principal we are given to be 6,000. So you plug that in there. And then we also know the interest earned. So the total interest earned is $400. That would go right here in the bottom right of this table. So now that we have all the pieces of the puzzle put together, now we can create 2 different equations with which we can solve. So typically when you are trying to determine the equations, you're going to look at some total amount to get our equation. So for example, we are told that Larry invested $6,000 in stocks and bonds. That is a total amount. And we see in the table that's down here in this total row. So we can create an equation from that. So look here at this this column. So we know the total is $6,000. That is made up of stocks and bonds. So from that we can get an equation. We know the amount invested in stocks plus the amount invested in bonds equals $6,000. So that's our equation. Stocks plus bonds equals $6,000. Now the other total that we can use is this total right here of $400 for the interest earned. We know the interest earned is made up of interest from the stocks and then interest from the bonds. So if you add up those interests, the 0.05s plus 0.07b, that must equal $400. And that was going to be our second equation. So we use the totals of the principal and the totals of the interest earned to develop our two equations. And now from here, we can solve. So over here we see the equations typed up again. And what may be helpful is if you can get rid of the decimals in the second equation. You don't need to, but it may be simpler if you do. So to do that, what we can do is multiply both sides by 100, because 100 has two zeros at the end, which would effectively move over the decimal point 2 places to the right. So you multiply this entire side by 100, and then this side by 100. All right, so 100 times 0.05 gives you 5, and then 100 times 0.07 gives you 7. So we now have 5s plus 7b, then 400 times 100 is going to be 40,000. So that was not necessary, but it makes things a little bit simpler to work with. And now, from here, we can use substitution to solve. All right, so what we do is we want to pick one of the equations, and we'll pick the first one, and you pick a variable to solve for. So if you pick the first equation, we pick a variable to solve for. Let's pick one that's going to be simple. So either would actually be pretty simple because there's no coefficient in the front. But let's solve for s by getting rid of this b. So let's move the b over here by subtracting. So now we have s equals 6,000 minus b. And then from here, we can substitute. So into the second equation, the 5s plus 7b equals 40,000, we can substitute the 6,000 minus b in place of s right here. So now we have 5 times 6,000 minus b plus 7b equals 40,000. Now from here we can distribute 5 times 6,000, 5 times negative b, that gives you 30,000 minus 5b. And then negative 5b plus 7b, those can combine. Negative 5 plus 7 would give you 2. So we have 30,000 plus 2b equals 40,000. And then from here, we can solve for b. So we can subtract over the 30,000. So bring it to the right side by subtracting. That gives you 2b equals 10,000. And then get rid of the 2 by dividing both sides by 2. So now we have b equals 5,000. All right, so we have b solved for. So we know b, the amount invested in bonds, is 5,000. To find the amount invested in stocks, we can just plug 5,000 in for b into either equation and then solve for s. So if we pick this first equation, the s plus b equals 6,000, we plug 5,000 in for b. Now we have s plus 5,000 equals 6,000. We can then subtract 5,000 from both sides. We find that s, the amount invested in stocks, is $1,000. So the amount invested in bonds is $5,000. The amount invested in stocks is $1,000. We can confirm because added together it gives you 6,000 for the total. And if you plug back into the second equation right here or back here with the original equation, you would find that we would have a true statement. One more example to work through. Here we are told that a warehouse has a total of 100 bags of cement. Some bags hold 25 pounds and the rest hold 50 pounds. How many of each type of bag are there if the warehouse stores 3,200 pounds? So to do this, I want to begin by establishing my variables. And so the question is asking how many of each type of bag are there. Well, we have 25-pound bags and 50-pound bags. So we can let x be the number of 25-pound bags and y be the number of 50-pound bags. So from here we want to create our equation. Well, actually, two equations. So we want to look at what we are given. So typically we want to look for total amounts of something. Here we have total amounts of bags, so number of bags. We also know a total amount of pounds. So we're going to have two equations, one of which deals with the total number and the other deals with the total weight. So looking at the first known information, the total number, we know that if we add the number of 25-pound bags plus the number of 50-pound bags, that will total to be 100 bags. So I take x plus y, that equals 100. So that's my first equation. Second equation has to do with the weight. Alright, so looking at weight. So with the 25-pound bags, the weight of the 25-pound bags, we take 25 pounds times the number of bags. So 25 times x. That is my weight. Right, if there's one bag, it's 25 times 1, or 25 pounds. If there's 10 bags, it's 25 times 10, or 250 pounds. It's 25 times the number of bags. And then for the 50-pound bags, we do the same thing, but we take 50 times y. 50 pounds times the number of 50-pound bags. And I know that if I add those together, those two weights, that total is going to equal 3,200. So my second equation would be 25x plus 50y equals 3,200. So we have our system of equations, and from here we can solve. So we pick a variable to solve for, and we see that the first equation, there's nothing in front of each variable. So we can pick that first equation and solve for either x or y. We will choose x for no reason, because either are fine. Let's solve for x, and we do that by subtracting y to the other side. When I subtract y over here, this is gone. We now have x equals 100 minus y. So what I can do from this point is I can then put in this 100 minus y in place of x. So in the second equation, 25x plus 50y equals 3,200, I put the 100 minus y in place of x. So now we have 25 times 100 minus y plus 50y equals 3,200. So to solve from here, I want to distribute 25 times 100 and 25 times negative y. That gives me 2,500 minus 25y. I can then solve this. Negative 25 plus 50 gives me a positive 25. So we have 25y right there. Finish this off, we can subtract 2,500. That will give me 25y on the left, 700 on the right. Divide both sides by 25. We now have y equals 28. So y is 28, which is the number of 50-pound bags. I can then plug into either equation. So let's plug it in right here, actually. This would be easiest if we plug it in right here. We could plug it in here, or up here, x plus y, or either of these other equations. Just plug it back in. We have x equals 100 minus 28 instead of 100 minus y. That would give me 72 for my solution. So we have 72 25-pound bags, and we have 28 50-pound bags. And we can check our answer because the total would need to equal 100, which it does. 72 plus 28 is 100. And the total weight should be 3,200. And I can test that by taking 72 times 25. Add that with the weight from the 50-pound bags, so 28 times 50. And that should equal 3,200. And if you work through that, you will find that indeed we do get that total of 3,200, which means we have the correct solution. And that concludes our lesson for today. We will see you next time.